Hey, welcome in. Would it be possible to fit a Saturn into the shell of a Sega CDX? Maybe. There's a lot of chips on the Saturn, you probably can't reduce the size much. It'd be a challenge, I think. It's quite a lot smaller, so I think you'd struggle with that, to be honest. There we go. Yeah, you can basically just search for your own name and then get a live up. Right, I'll see if I can. God, that's small though. I can't even see that writing. I need a screen mount there, really. Yeah, to be honest, that's pretty bad. Yeah, I'm just trying to get the. I was going to see if TikTok chat on the phone is any better than on the screen, but it's worse. So I'll just use the chat that's on the screen. Yeah, well, he's just been having a fuss. He's been loving his sleep, and then he's had a few hours by an electric heater, so he's nice and warm. We're just going to try, and well, we're not going to try. We are going to swap all the components off this PC Engine GT of our customers onto our new RePCB. So this is a remade board for the PC Engine, and the only problem is the customer's not paid for diagnostics but sent it in. I've put all the components in a bag, but they've just come loose in a box. Everything's in bits basically, and they've also worked on it, torn pads, burnt the board. There's kind of burn over here that they've mentioned. I think they've torn some pads up here potentially, lost a few components. So it's basically been worked on. It looks like he was going to start diagnosing and then has sent it in. You can see clearly the audio jack is completely rotten, so we probably want to grab a new one of them. But the only issue is, like I say, he hasn't actually paid for diagnostics. So we'll start with swapping over all the components and see where we're at. If we don't need diagnostics, if it works from simply doing that and a new jack, then we're fine. But what I want to do is while we're taking all these components off and going over, I'm going to make a log of all the parts we can, like at least all the common parts. I don't think I'm going to bother with the component tester for now on certain transistors. We could do component testers, and I'm just going to get all the resistors and caps to start with. And then we'll keep things like the crystals and the transistors labeled up on some sticky tape, and then I can come back and use the component tester to figure out what all them components are. Game Gear on the website, yeah, if you go to retro6.co.uk and then ready made on the homepage, we've got Game Gears in there fully built, and you can select what you want with them. So what I want to do basically is to take the components off here, and as I'm doing it, put them through this LCR meter, so we can measure the exact values and make a bomb, so that next time we make these, we can have them fully populated with a load of components, so a ton of resistors and caps and transistors already on. So doing the transplant is a lot easier. So let's just take a look at what the customer mentions is wrong with this. A bit zoomed in, but PC Engine, and then you see issues, but like I said, they haven't actually paid for fixing any of these. There's audio and video issues. We have unsuccessful recap by the looks of it. CC104, upper pad broken, which doesn't matter for moving it over to another board. Around 710, heat gun applied with too much heat. That's what we saw there. So this is the burn. So really, it sounds just like there's a torn trace, really. CC702. Not sure what's going on with CC702, but I'm sure we'll come to that as we're working through anyway. So either way, we'll start with moving these components over and obviously measuring them and then placing them on this board. They're having a new screen as well, which is good because these transformers are almost definitely not going to work when you take them off. They're very fragile and die. So these might be a problem for us, but because we're actually doing the screen, we shouldn't need these, so we probably won't even put these on to start with. One of them is for the backlight, and the other is for the contrast, I believe. I'd have to double check each. So we probably don't even need either of those. So let's figure out where we're going to start first. I think we'll remove this ribbon first because we're going to have to reuse this, and this is the cartridge connector. So we want to warm this up with hot air to get this off. And we just want to be careful we don't melt this wheel, because I don't think there's any replacement wheels of the same exact layout that are available. So we want to definitely avoid the heat in that area. We might even want to cover that up, because as we're moving we might forget all about that. So let's just cover them up from direct heat. You can see this is not really designed to be removed and reused. It's a very, very weak ribbon that's even melting from the low temps. So we might even replace this ribbon. It's got some corrosion, some electrolyte leak on those end ones there, you can see. And then this is just the housing of that ribbon still stuck. So it's just not really designed to be reused. That's just like been taped on. So I'm pretty sure we're going to replace this with a modern ribbon. We'll see if we've got them in stock, and if not, we'll order like a blue ribbon. I'm pretty sure I've got these in stock, and we'll reuse a brand new flexible ribbon, or we might even put a connector on here so we can plug in a blue ribbon. It's one thing I wanted to do on this RePCB is to put little pads either side here so we can actually tack a FPC connector on. I think I've already got them in stock, so when we get to that, that's what we'll do. Temp for that was 320 because it's quite a delicate ribbon, but normally I run 480. New PCBs for SNES, maybe, yeah. There's a whole load of things we want to do for the new boards. I think the Game Boy Advance will be next first. So that's that out. Oh, and look at what's happened with that as well. Melted the crap out of that wheel, even though we covered it up and there was barely any hot air. So we'll have to replace that. We'll try and measure. In fact, we can probably break that off then, look at the internals and measure the spec. But luckily I've got, I don't know if I've got any off mine. Yeah, these are all the components off the board I've got. But we'll now have to find a replacement for that. And that was covered up as well from the hot air and still melted. So that's super fragile, but like I say, we'll figure that one out. We'll measure what these pins do, get the resistance on that. So we might as well start with taking that off, I guess, and let's figure that one out. There's no real plan of attack on this, just taking the components off and measuring them one at a time before we transplant them back on. So we might as well start with the super melted wheel. And you get these two pads first, which anchor the wheel down. Once you've got them two out, you can then deal with the back pins separately. And now we should be able to just get all these together, and the wheel should come free fairly easily. There we go. So now let's see what we have in terms of values on here. Presuming the wheel isn't actually bad, ignoring the plastic part of it, if the electronics is fine, we can measure this and figure out which pins are which. But it will be easier, considering the plastic's gone, it would be easier to get rid of this arm, and then we can see inside. So let me show you inside these anyway, with my nice glued up cutters. We actually, before we do that, we want to measure the diameter of the wheel. So when we replace it, we know that. So we're talking probably a 14mm wheel based on the calipers there. So you've got to compensate for the slight bit of melty melt on there. And 13.6, I'm going to say that's either a 13 or a 14mm wheel. It's going to be 1mm thick, so that over there is exactly 1mm. So let's make a note of that. And we're going to start probably an Excel spreadsheet for this. So the idea of this is we want to, as we're going through, take a time and document every component on here, because I don't think it's been documented yet in terms of all the components. So if I can get this Excel spreadsheet up, we can pull that up on here, and then we can write in that we want VR502. In fact, we'll do a thing, so we'll do designator VR502, and then we want value, or what we can do here, value, and then notes. So this is going to be a 14mm diameter, 1mm thick, and it is 4 pin. We'll probably have to also make a note of the orientation as well. So you'll see when we look at this, you'll see what I'm meaning by why there's different ones. So this is a little rivet that holds it in. You can either try and get the rivet off, or you can just twist the plastic up either side to get to the rivet and then cut. So we'll just try and snap the plastic off and leave the rivet in, I think, on this one. So there we go. So this is inside of these wheels, so you'll know how they work. So on the back, this is just literally a piece of plastic, nothing else there, that attaches to this center swivel piece. You can see this turns, so that's when you're turning the wheel. And what happens is, they all look slightly different, but this is a metal bridge here, and this is another metal bridge here. And you normally have on each one, this is actually a 3 pin, and the 4th pin doesn't go anywhere. You normally have an inner and an outer, and then the middle arm is a blade that wipes over these 2 pads. So this will be a trace that comes up here, and then under this, that we'll cut off in a second, will be a resistive strip that goes around, and then it comes out of here. So over these 2 pins will be the resistance of the wheel, and then the center pin will be like a little 0 resistor blade that will come off the center of here and go here. And as you're turning around, that blade effectively runs along all of the carbon. So if you measure from here to here and the blade's shorting out, it'll be 0 ohms. And if it spins all the way around to the other side, you'll get the full resistance. So that's ultimately how the potentiometers work. And this is one that looks a bit difficult visually to see, but if we can snip that rivet, we should be able to lift it off. There we go. So you can see in here now, there's the black strip. So we can zoom in even more on that, to be honest. A nice close-up view. We could zoom in even more than that. There's the carbon strip. So this is resistive. So if you put your multimeter on here and measure, say, over these 2 pins, you'd get a low resistance of whatever the resistance is of this little distance. The further you go, so say there, increases resistance. All the way over here is even more. And all the way from end all the way around to the end is the full resistance. This might be, say, 10 kilo ohms. And then the center arm here, there'll be a little blade here, which might be that thing that's left and attached. And as you turn the wheel around, you can see that blade shorts out at different points on that wheel. And then effectively it means that when you measure from this pin to the center, it goes up here, shorts through here and down. And that's how you get your variable resistance as you're measuring. So this will actually be easy to replace, I would have thought, because even if we have to float a pin, it's only a 3-pin and not a dual wipe as well. So that one shouldn't be a problem to replace. The IPA bottles decided to give up the ghost as well. Ah, that's fell off, that's right, all broke. I think it just fell off. Thanks, Jimbo. Glad you're enjoying watching. Everyone loves to see me melt some things. I think it's the first time we've really had a mini disaster on a stream, but it's not that bad. This one's turned out quite well for what it could have been. So we'll go into resistance, and I'm going to measure over the outer edges, and if this is working, we've got a 4.447K. So I'm going to say that's a 4.7K potentiometer, and we should be able to, I can probably show you this so you can see what I'm on about. If I get this up like there, and we go over, say, the outer 2 pins, you can see we get 4.4. Now, if I go to the carbon and touch halfway up, you can see we get 52 ohms. And what I'm doing there is I'm basically putting one probe on here, one probe, say, here, and that's where we got the 52. And then if I move the probe up to here now, so about halfway, we should expect to see around the 2K mark, because we're halfway up the resistive strip. So if I touch on that about halfway, you can see there 2K. So as that comment mentions, there's not a standard in between 4.4 and 4.7 really for potentiometers. So this is going to be a 4.7K potentiometer. And we want to say the pin out of it as well. So if we go to the board, because we want to make notes of the pins, it's labeled, so you can see it's actually got blank 1, 2, 3, and that would be here. So we just need to make sure when we write it in the Excel spreadsheet, we can actually figure out what we mean. So I'm going to write pins. Well, I don't think we even need to write anything because it's just a 3-pin potentiometer. But you'd normally have to make sure you make a note of where the pins are. But on the board, it's very obvious. It literally says 3, 2, 1. So all I'm going to write is 3-pin or 1-pin disconnected, something like that along the notes. So when I come to look back on it, it makes sense. So I'm going to put 4-pin, right pin, not used. That should be enough for us to now find one of these. So we can scrap that because obviously the melted ones are of no use. And we can move on to the other thing. So this wheel then will probably, this one's more complicated, but I already did this on the wiki. So I've already got this wheel for the volume figured out on the wiki. And this is the same as a Game Boy Color wheel, but reversed. So the Game Boy Color is effectively 1, 1, 2, 2, 3. It's like this wheel exactly reversed almost. But this one really needs to be, I don't know whether I cut this one open on the wiki. Ideally I did, so you could see. Let me see if I can pull an image up. PC Engine GT. Audio circuit. And then we have the audio circuit here that I reverse engineered before I made this board. And I'm sure somewhere, here we go, I made notes of the volume wheel. So pin 1, where it goes, pin 2, 2, 3, 4. I did the headphone jack, but I don't think, unfortunately, I didn't show the insides of that wheel. So I thought I'd already reversed that, but I haven't. So we're going to have to figure that out as well. I don't know whether we tackle all the plastics first. This we don't care about. We've got a new one of these headphone jacks, and it's absolutely corroded. So we're definitely going to replace this, because if you look inside of that, you can see that wheel or that headphone jack is completely corroded. So we can take that off without any worries, because we're going to replace that. So we need to get the DC jack off nice. We've got a new power switch as well, so I'll probably fit a new power switch for him, keep everything nice and clean. So really, the inductor will come off. This is the only thing that I think is risking of melting. So we might get this wheel off first now before we do anything else. And then we can hot air this off without worries. So we'll take these two things off then, DC jack off and this wheel off. And then this will have no issues coming off, this won't melt. And this we don't care about because we're going to replace. So let's start with that. And then we don't have to think too much about the rest of the board. Nothing's going to be in danger, if you will. So we'll take this off by warming up these two pads first. And I'm just going to get tweezers under here. So I'm just going to wedge my tweezers right between the PCB, so the green bit here, and the metal of the wheel, like that. So I'm applying a little bit of pressure. And then while that's in there, I'm going to warm up the two solder pads. But first, before I do that, I'll put some fresh solder down. And in fact, that wheel we've melted, I don't technically think, even if we had the same pin out, we need the same pin out, because it's not even used, because the customer's having the screen upgrade, this upgrade that doesn't have an adjustable wheel, because it's got the correct contrast. So that wheel's actually not going to be used. But we do want to try and obviously put a nice wheel on there either way, and ideally the same spec, but it's actually going to be redundant in this build. So it's not the end of the world if we don't even find that exact wheel anyway, because as long as we can fit a wheel in there for visual, it's not going anywhere. It literally won't connect on the board anywhere to the circuit, because the customer's having the modern screen upgrade, basically. Now, this doesn't want to quite come off the mounting holes either. There we go, I think we're getting somewhere now. And these are definitely awkward things to remove and reuse. Nearly there. Don't know whether to attempt this from this side here now to warm these up. And what I'm going to do here as well, just because we don't want to melt this plastic, is they're mostly out. I'm just going to take those little anchor points off now, so we don't bend too much, because otherwise, if we're going to bend that much further, I think we're going to end up causing damage. So we'll cut them off so we can then lift this out cleanly. And we can probably hot air those pins that I'm on now, if we need to. We're working on a PC Engine GT that a customer sent in for completely swapping over to a new board. So at the minute, what we're going to do is take off each component one at a time, measure and identify it as well, and make a bill of materials on this that helps us identify every single component on this board. So when we come to make this board again, this RePCB, we can have the factory populate it with all the caps, resistors, transistors, and the customer should only really have to transplant, hopefully, a couple of chips. So we're going to work our way through that. It'll take quite a while. I think now the plastic's off, lifted out of the way, I'm going to hot air this now, because I just prefer the hot air, but I wanted to make sure the plastic was out of the way first, otherwise we'd melt the wheel like we did the last one. I've got a desolder gun, I mention it every time, the rip traces. So to be honest, the desolder gun on this case wouldn't matter because we're changing boards, so I could actually use that, but I don't use the desolder gun. I use a solder socket with a silicon tip, so we don't do any damage to the board. But I use hot air with that, so whenever there's a risk of melting anything with the hot air, like the plastics, we can't really do the desolder. We could also use desolder wick, but it wasn't that bad. We've got it off, and then we can now clean up the excess solder when we come to put things back on. We'll just use some desolder wick to clean that up. So we want to now figure out what this wheel does, and these can be tricky without opening them up and looking to figure out when you're measuring them, because there's so many different variants. They can be quite tricky to figure out. So what I'm probably going to do is take that off and leave it for now. We're not going to try and figure out how that works at the minute, because a 5-pin one can be a dual wipe. It can have two different versions. So we'll leave that one just for now, and we'll come back to him. But what we will do is measure pretty much everything else going forward. I'll just leave just that one for now. We've got it at the side, and we'll bounce back to that. This port we're just going to get off completely because we don't care about it. Like we say, we've got a brand new one. This DC jack then we will get off. So before we can get the DC jack off, we have to get rid of this either insulation or vibration coating. And the fact this is just over, I think like the DC jack and stuff, this is probably just more for, I'd say, protecting maybe one of the high voltage traces runs up here somewhere. And I think, yeah, maybe it does. I'd say so, because this is looks like high voltage insulation. And it looks like it's got the, this has got the inductor under here. So we'll replace that with a fresh inductor as well. That looks like it's breaking up. I can see the exposed inductor a bit with the glue being on it. So let's hot air him off. And these inductors we can measure, but these are just purely fairly standard inductors. They're just for a bit of noise suppression that doesn't really work between the different sections of the board, like the different parts of the circuit of the board. He's gone flying already, nearly tried to walk off, so that's the inductor. So we will keep him to one side. He looks intact. I thought he didn't, but he's completely intact. Yeah, so he's fine. So he's here. You can just about tell where he is, covered in the coating. So there he is. You almost can't tell he's an inductor. So we'll measure him in the LCR meter, because that's the whole point, to get the exact values. Let's just try clean him up first. Best screen for the original Game Boy. Depends if you want originality, then you can backlight the originals. If not, all the IPSs for... have they used a resistor and called it an inductor? All the IPSs for the Game Boy are fairly standard. We're making one soon, but we haven't had time, so I'd say the high-speed Edo or the funny plane at the minute for the GBO, but personally we just use the high-speed Edo ones. That just looks like a 330 ohm resistor to me. On a... oh, it is, that's why, because it says R517 pointing to that. So the inductor is here. So we've got R517, which we can make a note of, and that looks like it's going to be 330 ohms. It says 331, so if we're careful. I thought it was quite small for an inductor. Yeah, 330 ohm, that is. Backlighting the original probably wouldn't be far off the same price, yeah, because it's quite a difficult task. We haven't listed it yet as an option. So we don't actually have it as an option, but we can do. Right, so let me just make a note of R517. $330 ohm. We don't need the footprints because we've got the original boards, so we can figure out the footprints after. Next up, we'll try to get this inductor off. I think the inductor, to be honest, has already fallen apart with being covered in this coating. I think it's it's an open top, so that inductor's gone anyway. So that'll be one of the ones I was mentioning for noise suppression. This is on the, this is the diode down here. So there's the diode, there's the inductor, but the inductor's literally missing off the top. So Al502, we don't know the value of because it's already in bits. That one's going to be a fun one to try and get from a PC Engine GT without the component coming apart, because it's just covered in all of that coating, and it's one of the open wire wound inductors by the looks of it. All over the board, this grey stuff is like it's normally used for thermal on capacitors, but in this case it's used for I'd say the high voltage of the backlight. If any parts of the circuit run, it'll stop arcing. So that's the inductor off, but pretty sure that inductor went with, you know, the lid come off when we took this gunk off. So we can't really measure that one, which is no matter. I've got another one as well we could try and measure. So Al502, we'll just put a question mark on for now. And I can figure that out one way or the other, either from one of mine or another. And what we can do, if we're unsure of what's around here, for example, we can get this RePCB and look at the footprints. So we can easily see there's a resistor here, an inductor here. We've got, it looks like another inductor here, apparently, which I haven't seen. But there's one under there as well, in what looks like just as bad a state as well. So I don't think that one is going to be much better. I mean, what we could do on this one is try and expose the pads, and you can see why they're so fragile. Look at the top of that, just ready to separate. We can try and get the LCR meter on these two pads and measure it while it's in situ. It's an idea. And then I'll probably, to be honest, I'm going to tack some flying leads on this because we're not going to get the LCR meter probes onto them pads. And we don't want, well, ideally we don't want long wires because it's going to add a bit of inductance to it, but I think for the accuracy it's not going to matter. Just tap that side and tack another one the other. If we wanted to be really accurate and these were low, we'd use little pogo pins poking up. We wouldn't use flying leads because these leads again have a bit of inductance in the self. So now with that we can connect one probe here, and then it's going to scan through and try and detect. And the problem with it being in circuit is it might be connected to other elements, so it might not detect correct. And if we tell it that it's actually an inductor, it'll try and scan for an inductor. This has got 300 nanohenry, which doesn't seem right. We can change the frequency, and that will change the value. Normally 100 kilohertz is a standard testing frequency, so we're getting pretty consistently a 350 nanohenry, which does not sound right. So either that inductor's bad, or with it being in circuit, it's not measuring right. So now we know what it potentially is. Let's try and remove it to see if we can get it off without damage and measure it again. But you can see this has already got quite a bit of rot. We're also next to a connector that, to be honest, let's probably, well, that connector's going to be fungi enough. It's wedged between the choke here that we've got and the solder pads for it are underneath it. So we're going to have to try and remove this choke first and then remove that. So to be honest, let's do the thing that I don't do, which is using the desolder pump, because we don't care about ripping the traces on this board because it's having a new board. So let's just use the, actually I can't be bothered to set it up. I have to make sure the cartridge is clean and set it up, not being bothered with that. That makes more sense. It's a surface mount connector actually, so we can just desolder that. And I don't think there's anything else holding it on. So I think it is just a surface mount connector there. That'll just come clean off. So let's get this out of the way as well. This should be as simple as warming up both of them pads and lifting that off. So that's out the way, nice and easy. We probably still want to figure that out as well. We want to try and get the, ideally the part number for this, so I can work with the factories to figure out that exact connector, and then we can make that in the bill of materials. So first I'm just going to put some tape around it and write on what part it is. And then we can come back to that. Let's clean the desk as well of these bits of gunk I've got, otherwise it'll just get messier. And anywhere the components were taken off a standard, like resistors and caps, I'm not going to use the originals, I'm going to put fresh ones on. There's no point in putting the old components back on once we figured out what they are. So this, if we use this board, we can find out that is not really, I don't think it's even labelled. We've got the inductor, cap, another inductor, cap. CN500 that is, so it's kind of strangely labelled. You have to look all around the board, but it's this CN500 here with a little arrow that points to there. So this connector we want to label CN500. So what was the plan? Oh yeah, we were trying to get this DC jack off. That was what we were in the middle of doing. So now we've got this area a bit clearer. We want to get this DC jack off. So there's a pin at the back here, a pin at the side there. So if we flip over, that will be, it'll be this pin here, and this pin here, and this one. So it's going to be these three pins that we need to warm up at the same time for the DC jack to probably drop out. Corrosion, there's corrosion all over the board, but this grey stuff is just the, like here, this is a high voltage cap, so this will be to stop high voltage arcing. Same here, there's transformers, so this is trying to stop all that arcing. But there's corrosion here, corrosion over these components, there's corrosion in here, so the board's pretty bad in terms of quality wise. That's my LCR meter complaining at me because I've left it turned on. So let's try and warm all of these pads up at the same time, and the DC jack should just fall out. It's just caught on the other side on something. Yeah, these are just all falling bits, these components. They're not in good condition, so I'll probably try to source a replacement DC jack as well. I think all of the plastic on this is just not doing great. Yeah, that component is just not coming off clean either. So I think we might have to, well, we will have to swap that as well, that DC jack. But it's not the best of condition anyway. It's like got a bit of corrosion in there. So we'll swap him as well. It's a fairly simple DC jack. And that's just, well, we don't need to clear that hole up, but yeah, this board is not in good condition. It's probably all the electrolyte that's leaked over the board and has obviously made all the connections very bad. You can see the fact that it's in all here as well. It's kind of leaked all here. So these caps are just destroying the board really. But I think if we'll measure that DC jack in a second, and we'll see if we can find one of them, because it does look completely standard. There's probably a standard console this is on, like a Game Boy Color or something. Oh yeah, this is going to be it's going to be a big job, this one. We're just working our way slowly through a rotted PC engine, and at the same time we're trying to measure all the components and find replacements for them, and you know, get this all like a brand new PC engine. So we're just taking it one component at a time, but so far I don't think we've taken one off that isn't falling to bits, other than a resistor. But we're starting with all the main plastic bits first that are the most risk of being bad. So once we've got these off, we shouldn't have many issues after this. So we've got that DC jack off. And now what we need to do is, it's not good enough to put back on, but we want to measure like this gap, which to be honest, we've got the footprint on here. So we don't need the footprint as such. I can measure the footprint here, these holes. So we know the spacing of it, which this fits in here, basically through there. But what we do want to know is the size of this opening and the tip inside, so we can try and find a replacement. So it's got a 4mm opening, and then the stump inside is 1.2mm maybe. So what we're looking for is a 4mm opening with a 1.2mm tip. I'm wondering whether any of the existing consoles we have a DC jack like that already. It's worth having a look on like the Game Boys, for example. So we'll grab a few of those and see if they match. Did you do? Should do my going to be good if I'm space. On there. So just get to it. Yeah, just put a thick piece of foam so it's not directly on it. So that's where it goes. Like I put it right on there. Probably the tips to do it as well. We might have found one. I don't know whether it's the same, but see what you think of this. So this is a Game Boy original. And there's the opening for the Game Boy original. And there's that. I think it's a bit smaller. Yeah, it looks a bit small. The tip looks right, but I think the opening's a little bit smaller. Oh, I don't know. Measure's the same. Yeah, not quite. Measure's 3.3, so I reckon that's a 3mm, and the PC Engine's a 4mm, but it wasn't far off that. It was worth a shot. Put them down there. The meal, yeah, it was lovely. Yeah, really enjoyed it. It's better than fixing rotted PC engines. What other consoles have got a DC jack? I don't think we're going to find it that way, so let's jump on. Where can we go on? Probably, as strange as it sounds, you can probably start on either AliExpress, because they have a lot of spare parts for it. I don't think we'd go on places like DigiKey for something like this, because this will be an old style DC jack. So I'm just going to search for DC jack 4mm by 1mm. That seems like it's a standard size as well. And yeah, it's not that one, so it's going to be, looks like it's going to be super easy to find anyway. There's quite a few here. So yes, I think all that'll end up being is one of these kind of connectors. You can see the standard sizes here. So it says like 4mm, and then there's 4.8 by 1.7. And what you have to bear in mind is that some of them will say a certain size, like 5.5, or the most common one is 5.5 by 2.1, I believe it is. And this one says 5.5 by 2.5, but it's a 5.5 by 2.1. So what it'll probably be is, I reckon it's going to be this 4.0 by 1.7, even though the pin measures 1.0, that's probably going to refer to the size of the opening in the plug that goes into it. So we'd probably grab a few of these. That seems like it's the one, and I'll just grab a few more sizes as we go. And you can see the pinout of the foots looks fairly average and standard. So I think those will fit. So I'm not concerned about finding one of them, but we'll make notes of what we've measured. And then that's the other one that we should be able to replace. And like I say, the goal of this is to replace as many of these components anyway with new. That's part of what we want to do with doing all this measuring and figuring out. We want to spend the time figuring what all these components are and trying to find alternatives so that we can fully populate this board. Basically, that's the goal. So we sell this board, but we don't sell many of them because of the amount of work. Because obviously you imagine the amount of work this is going to be now to swap all these components over, and customers don't really want to do that. So if we could get all of these components pre-populated, and it's double-sided as well, then it makes this job much easier for the customer. So it's going to take us a while to figure all this out, but it's going to be worth it in the long run. Yeah, we've actually got the, that's a point, I don't even know if I've got the PC Engine plug for this one. I'll probably get an official PC Engine GT jack there to make sure that it fits, but it's a fairly standard one. So let's just tape him up and write on that he is, what was the connector for this one? TP509, this one is. So we'll put notes in the spreadsheet as well while we're doing this. TP509. Hi, welcome in. We're in the middle of reverse engineering all of the components on a PC Engine GT at the minute. DC jack, 4 point, well, there's no value actually. It's going to be DC jack 4.0 by 1.0 millimeter, possibly 4.0 by 1.7 millimeter. That's the notes on that one. This is TP509. Next up. Oh yeah, PC engines are very expensive. And best of it was, to make this board, I gutted a completely working PC engine, like a perfect condition one as well, because I had to have a perfect unrotted PCB to design this from. I've made it exactly the same, so this isn't like a redrawn PCB. These traces all go exactly the same as the original. So if we were to, say, flip over, there's different variants of the board though, and you can't see through very easy, so see all this reflection, but see those traces you can see running up there. You'll see them on this board running up there as well. So we've got R700 there, and then you've got those traces running up there, that little reflective line. That's those traces running up there. So this is a one-for-one clone of this PCB before I started like redrawing things. Right, so now let's get, I did say we had the power switch and we don't. I've got the power switch for the PC engine, not the GT. So again, the power switch will probably want a source, but again, I'm not going to bore you with that. And all I'll do for this is measure the values and hunt around AliExpress for switches with the same layout and footprint until I find them, basically. And I should be able to find them. And then once I do, the factory can have them. And to be honest, based on how the last few removals have gone, and the fact we don't care about burning this original PCB, I am actually going to get this desolder pump out. The thing, like I say, I never use these because of them. As I see even working, I never use them because they burn traces, so I don't like to use them. Alright, so This is a Hakko FR301, and the reason I don't like them is they always seem to, they probably won't on this one, but on most boards that have got delicate traces, these things can burn up the PCB fairly easy. And if you're desoldering, say, a dip switch with loads of pins, by the time you go down and remove a few, half the time you've ended up burning through traces, and then you spend your time trying to fix trace damage. So I just don't like them. It's just something that I think they're not worth doing. But in this case, to remove, it's probably the perfect use for it when you're not going to use the original board, basically. So you put this over like a soldering iron, press, and it clears the hole. That's the idea. And this is instead of a soldering iron and desolder wick. But I find the tip, you know, this hard tip pushing on is what ends up causing the traces to rip. So that's why I don't like them. One left. And then you'll find as well, normally the legs stick to the edges of the holes and it doesn't come off anyway, because as you're desoldering, these legs will stick to the edges. So sometimes you still have to break them free like that. But there's the switch out nice and easy. So obviously they do the job of what they should do good, but I tend to find, like I say, they damage the traces on, not necessarily these boards, but a lot of boards I've seen where they can damage traces, and it's not worth the risk. I prefer to take the time with the hot air and desolder pump where you can, but this is again, that's why I own the tool though. It's just very rare I'll use it. Right, so that switch, we don't need to label that switch as such. It's very obvious what the switch is. We will put it in the Excel sheet though, so we know that we need to actually find it. So we've got a reference to it. And that is SW500. What else do we have? We've got the choke, or the, again, filter here that we want to remove. And that is X, no, that'll be, is it X500? Yep, I think it's X500, they've labelled it there. So this one's X500. They're 3.5 by 1.1. Yeah, actually, it probably will be. The OD of the hole is 4mm, but obviously it'd be too tight if it was 4. So yeah, I'm going to change that note actually. It's going to be, yeah, it's more than likely going to be a 3.5 by 1mm. That makes a lot more sense. Or a 3.5 by 1.1, that just about fits over. That definitely sounds right. So that'll do for that one. If anybody wants to search for this as well, a power switch, you could search for it while we're doing this. The way you'd search for it is check if it's a single throw or dual throw. So we've got 2 rows, and we've got, so that's a dual throw because there's 2 throws inside 2 mechanisms, and it's a single pole because you've always got the common in the middle, and a switch has to have 2 points of contact. So this is a single pole. Single pole dual throw, if I'm not mistaken. So this will be a SPDT switch, and I can get the measurements of the pins in the center. So over the 2. 0.4, so 4.2 it looks like roughly. And we've also got the holes in here, so this looks like a 4.2 mil pitch roughly. Actually, no, I measured that way off on my own out. Or have I? Yeah, I measured that way out. I managed to measure so far out 7.6, 4.2, so somewhere in the region of potentially a 4 mil. And 7.8, which is close to 8. So I'd say they are 4 mil spacings between the pins that way. And then approximately 2.2, so maybe 2 mil spacings this way between 2 and 2. It'd work if it was 2 to 2.4 probably. So we want 2 mil gap there, 4 mil gap there. And the shield will be 12 mil that way, pretty much bang on. So 12 mil for the shield. And I think I've looked for this before and I can find this gap easy enough, but I struggled to find one where the shield fit, if this is the one I've tried to find before. And the gap that way is about 6 mil, so 5.8, but probably if you set this to 6, yeah, you can do 6 mil. So that's the measurements if anybody wanted to try and find it. Hey, welcome in from the US. Yeah, we're going to be on this for a while. It definitely won't get finished today, not even close to. This is a big reverse engineering job. Let me just check out that eBay link. Yeah, they look like it. So that DC jack is definitely a 3.5 by 1.1. That is definitely what that is. So I'll order some of them. Power switch we need to hunt for, but obviously we'll move on from that. This X500 is it's going to be like a basically two coils wrapped around each other forming a choke, usually for a positive and a negative to cancel each other out. We're definitely not going to find a direct replacement for that. It's just got a ferrite bead wrapped around some copper though, so any other choke in a sense will do for this one, but we should be able to get that off fine. Probably, yeah, I'll probably use the desolder pump again for that one, to be honest. Should have just kept it out. So we'll want this pin, this pin, this pin, and this pin. We'll let this warm up a second. And I'll probably put a bit of leaded solder in to make it flow easier. That's it. There you go, it hasn't come out at all. And still not come out, so that's a fail for the desolder pump. Let's put some more solder back on and give it longer before we press the pump. See if that helps. How would you get good at it? Just practice. Just continue to do something over and over until you get good at what you're doing. You can always improve. Right, So what we're going to do is leave this on, and because it's a big, effectively heatsink with it being an inductor almost, we're going to leave that a bit longer to try and warm up through the board. And you can see that black ring, how it's burning the PCB as well. This is exactly what I mean with these. They're already completely destroying the PCB, and it still hasn't done anything to get it out. So there's an example. So let me know if you think I'm doing something wrong there, but that's exactly why I generally don't use these. By the time they work, they do more damage to the circuit board than doing it through hot air. So we might as well get this choke off at the same time as then we'll move straight over to the headphone jack and get that off at the same time. Building, we are moving components off of a broken PC Engine GT and onto a new board I've designed, which is basically a 1-for-1 clone of this board. And you can see how easy hot air is. No damage, no melting whatsoever, no issues. But look at the damage that desolder pump's already started doing. It's eating into the rings and burning away the PCB. That's literally the reason why I don't use them. So whether it's a skill issue or not, but it's exactly why I hate those guns. They seem almost as useless as they can be. They do more damage than possible. So that's why I just stick to hot air and a silicon tip desolder pump. And there you go, that's the headphone jack off, no damage. So you can see typically when the board isn't fragile, you don't normally have issues with the components at all. Like, you'll normally get them off nice and clean. And obviously this one's rotted, so we need to swap it. But I think the components we've started with are quite rotted anyway, so that's why like these inductors falling apart and things. I think it's just the bad, basically, the rotting. I don't think it's so much so that we can do much more about it. They are just quite rotted components. So the headphone jack, we don't really need to label on there, nor do we need to label that X500, because again, it's a single component we can't really mix up. But I'm going to add them to the sheet. So we've got the X500, I'll just make a note, large 4-pin coil. And then we have the headphone jack. I've already got the replacement headphone jack, so we don't need to source that. But that is J100 maybe. Yeah, it's J100. So one of the hardest things on this is to figure out where the designators actually are. But I'd say in this case, here's the headphone jack, the X500's here. Here's 4 designators. L100's this. VR100's this for variable resistor. And it's matched by VR502 over there, so we know it's not that. R718, well, we know it's not obviously this and this. It's going to be this resistor pack potentially. But either way, this isn't a resistor, so that leaves the J100, which is for connector, the J. So this is almost definitely going to be J100. So we'll label that J100 with a note of audio jack. And now the fuse, we already know it's just a 1 amp fuse. It literally says on it. So we want a 1 amp fuse, F500 1A. So that's no mystery. F500 1 amp fuse. So we can just take him off. Let's get this desolder pump out of the way again. Don't think we're going to be using that. do we just tackle these connectors as well? These connectors, again, should be easy to source from China. They'll be still in production, but we're just going to take these off clean. Here's, get a phone holder. We want to come in from the side. Probably going to melt the phone holder doing this because it's a small board. Like that, maybe. I'm going to get the hot air from underneath. Like so. And then lift these off. If we put a bit of flux on, it will help, not necessarily with removing them, but it will give us a visual indicator that when we're warm enough, the flux will start bubbling. So we can probably, to be honest, I could probably get this on the overhead, maybe. I don't know if it's going to zoom out enough to be in focus. I don't know if that's too high up, just about there. So if I now get the, there we go. Get that there, get the hot air underneath, so you can see nicely. And then we're just waiting for this bit of flux probably to start bubbling. You can obviously just try and lift when you're ready, but the flux will give you a bit of a hint at when it's ready. There you go, you can see the flux just starting to bubble on this one here. And because this is leaded solder, I presume it'll be leaded solder. This is taking a bit longer than normal, plus we're heating from the underside, so it takes a little bit longer. Flux use styrene, that's what I'm using here. That's what you want to use. There we go, that one's lifted off. Now the board's warm, the other ones will probably come off not far between. There you go, that's that one. And the last one over here is a bit further away from the heat, but again, shouldn't take too long because the board's quite warm now. There we go. That's the connectors all off and fine, and the physical connectors are all intact, no issues, no burns. So we'll reuse them for now because they're nice and clean. I don't think there's much benefit in replacing them. They don't seem worn at all. Rating of the cap that comes with the clean amp. Which amp? Which cap, sorry. And you mean the clean power? It's a 680 microfarad or higher 6.3 volt cap. So we've got them 3 connectors, they can go over there. We'll label them up, but again, we're not going to put any notes to find them yet because I'll do a lot of this searching offline, not sitting on video searching for components. So we've got CN201, CN700, and CN200. And if I remember rightly off the top of my head, looking at these, I think CN201, I've written it all in the wiki already, actually, so there's no point guessing. Just go to the wiki and we'll see what they are. One's the front board, one is the LCD, and the other is the side connector for the extension port, I believe, for like the antenna and things. Let me just pull it up. So LCD circuit, yeah, so CN201 is the LCD ribbon. That's when the notes, LCD ribbon. CN700 is, we'll find out. Well, it's got to be the front board because it's the large one, so we don't even need to look for that really. CN700 is the front board connector, and CN200 is the side connector, side X connector, I believe. So that's them done. Where's the TikTok chat hidden as well? There we go. The solder remover I'm using, that gun was a Hakko FR301, but I don't recommend them. I never use them. But what I do recommend is hot air and a desolder pump. This one's by Engineer, but get a silicon tipped desolder pump and basically pump the solder out when it's hot. You'll do a lot less damage. Not using the ESD Max, I've never seen the need to, never had any issues from it, basically. Alright, so that's them off. Let's get this little plastic off over here so we don't forget. Again, the customer's not going to reuse this. This is the high voltage backlight, so the fluorescent tube. But I've got a feeling it's going to be an SMD mount under here. No, it isn't. It's a through hole from this side. So the pins are going to be under here. The wheel on the Hakko is set to, it's only set to 3. So 3 is 450, so maybe it's a little bit warm, but the hot air I run at 480 as well. The soldering iron I run at 400. So it's not much different than the iron, but I understand people use them, clearly. Just my preference is they never work for me personally. I've tried multiple times with them. They either tear the traces or they don't even work, compared to just getting the hot air on like we saw, and it took 2 seconds to take 2 components off. They don't even save time in terms of, it's literally quicker to hot air off than it is to desolder pump. The only downside with hot air is you just have to be careful of things melting. Basically, that's your only downside to the hot air, is if there's things in proximity that are meltable, then you're kind of stuck sometimes and you have to use a soldering iron and desolder wick. That's that connector off nicely. So again, we'll make a note and I will try to source these. What I might do as well is just, I could save myself a lot of time with all these connectors, just ship them off to the factory in China that I use and say, can you find me replacements, so they can just have the bag with physical components, and that's what I'm going to do. So I'm going to send off all of like the plastic connectors and even things like this, and just ask them to source locally all those parts. Saves me a job. And then when we get them, we can even offer a kit of all the plastic components in one bag and sell it as a product. So like the headphone jack, the DC jack, the power switch, the connectors, this connector here, sell like a bag of all the main things on a PC Engine GT that are going to melt when you're doing this work, and sell them as like a repair kit. That would be quite useful. So we'll do that. Better just save this Excel sheet in case stuff crashes as well. PC Engine GT bomb. This connector is, where did we take it from? up here. CN900. That's backlight connector. Is that done? What else can we get off next? So nothing on this side now is fragile. And nothing on this side is. So I think we've done all the work where we're worried about the things like plastics and connectors. So I think next we'll get the shield off then. We'll get the other side of the shield out the way. And the quickest way to do this is just, if your iron doesn't keep turning itself off, I'll warm the pad up of, say, this part of the shield. So probably easier to try and show you from directly top down if I can. So there's a connector here. I'm going to put the tweezers in and apply a bit of bending force outwards while I warm up here, and just bend the shield out. So you can see how the shield's starting to bend out there. If we warm that pad up, you can see I can just lift the shield out. So it's not all the way out, but it starts to move. And then you move to the next pin. So the next pin's here where the customer's burnt the board a little bit with the iron, I believe, possibly trying to remove the shield. And we'll put the tweezers under there, pull up like this to apply some anchor force. Warm that pad up, and you can see then that one's come clean out straight away. Then you can go back to this one now, apply the force there, and that one's all the way out. So you can see that's floating now, completely out. And just carry on going around and doing that on all the pins. Now we got the shields practically off now. I think there's just one over here. And this has got lots of electrolyte all around it, so the solder doesn't want to flow to that very well. So now one more in the center. And that's just come off without even applying force there. So that's that cage off. Let's clean up this board a little bit now. Yeah, all the fumes. I should probably turn that extractor back on. Right, this is finally ran out now, the Styri ASM. So it's time to move on to the Styri HTTF. We'll see if this is any better than that one. Yeah, I could potentially try another desolder station, because it would be nice to be able to desolder pump things sometimes, but I've got pretty good with the hot air that it's only really an issue when you can't use the hot air due to plastics being around, and the PC Engine GT is one of them exceptions where you could really do with one. But but there's rarely a need where I'd ever say I need one. But I could always buy one at some point, like another one, because obviously that hacker wasn't cheap in the first place, but they're pretty useless. That's a bit cleaner. Right, and so what do we do next? They're all normal components. Do we get these two big caged transformers off here, T900 and T500, because these are not going to be used. I'm pretty sure both of them won't be used in the new one because we're doing a modern screen, but we still want to get them off, and I can run tests on them as well to find out the values of the the turns and the coils and stuff like that. But I don't think you're ever going to get replacements for them, unfortunately, one-to-one replacements, just because they won't be. They'll be geared up specifically to. In fact, I've done all this on the wiki. I keep saying this, and then I've already done it. So I actually tested all these, and if I pull up this, you can see I've already done this, taken T500 off, figured out all the ratios and what it does and how much current it needs. I haven't done it. Actually, I might have done it for the other one as well. Backlight driver. I bet I've done it for the other one. I've done it for the other one in terms of pinouts, but I didn't do the turns and coils on it. No, I didn't. So the big one I haven't done it for, but the other one I have. Right, so do we? I'm tempted to just hot air this off. But if we hot air this off, probably a lot of other components are going to come with it. Let's just get under here first. And unfortunately, this is one of the most rotted areas because these two caps that the customer's removed, this is where all the rot normally creeps into here. So we'll probably find, again, this area of the board is going to be pretty bad. Or at least the component under it. So one giant inductor under here. Making a mess of my nice clean desk again. And this has got 101k, so that means it's probably going to be 100. No, it wouldn't be 100. It's probably a 10 microhenry inductor, maybe. It's just a wire wound. You can see by the shape. So we might as well get this inductor off if he's in one piece. It looks like he is, so you can see if we zoom in there. This is just what's called a wire wound inductor, so that literally the wire's been wound around it. So you've got this core here, this material, top and bottom, and then a core runs through to it, basically increase the flux inside. And this is just copper, insulated copper wrapped around the inductor. So this one looks perfectly intact. I'm going to hot air him off and we'll get him on the LCR meter. And then we can actually write down the exact spec of this one as well then. And that's something we can replace nice and easily. Let me just hoover this up again. I don't think you can. I don't think the inductor's the same as the Game Gear. If somebody's tested that and can confirm, that's good to know. But I'm pretty sure it's not the same one. So here is the Game Gear one. Obviously looks similar, but do we even have the same pinouts? 1, 2, 3, 4, 5. 1, 2, miss 1 and 3. And then on here, yeah, it's got the same pinouts. But I'm sure when we looked at that, we considered that and looked at it, and I'm sure it wasn't the same. But yeah, maybe it is. What we could do at some point is either get the working, I've got another working PC Engine GT with an original screen. We could swap the transformer out, but if that is something, that's really good, because we can rob tons of these with all the clean screens. We'd have loads of these spare. So that's if that's true, that's pretty wicked. And it would make sense in one way, because it's the fluorescent tube driver circuit. It's boiling in this room. Look how red I am. All the heat. Right, let's get this inductor off. Inductors come off nice and quick with hot air because they're obviously all metal, so they're conductive. So they tend to come off pretty easy. And again, we don't care about damaging this PCB because we're more bothered about preserving the components than the circuit board. It's obviously going on the brand new circuit board. There we go, and that's that inductor off cleanly. So now, let's test. You can normally find some components as well. Based on what's just written on them, you can normally find out what they are. So 101K inductor, if you put it in Google, you'll probably give me a hint at what you think it is, and then we'll point through this tester and see if we are right. Don't really need to get those bits off, so let's just leave that on. I can touch on these pads easy enough, but for the sake of holding the probes on while trying to do stuff, I might as well just tack some wires on again. Saves me having to hold them. As well, I've cleaned the audio up as well. I enabled some filters yesterday when I realised I'd not been running the audio through filters. Then when I listened to the stream back in headphones, I noticed as well, as a few people did and commented, it was slightly distorting the voice, almost sounding like it was clipping. So I've altered the denoise profile, and you should hear the voices a lot more normal and natural now. It's just you won't get the background noise. I think I've underestimated how long this task is going to take as well. I thought, yeah, I'll just take off every single component off the PC Engine and put it through a meter, make a note, make a spreadsheet. This is going to take a long time. Right, so this is, let's see if it figures out. It should figure out it's an inductor because it's off the circuit. There we go. So it is actually 100 microhenry. So I thought, obviously 101, like on a resistor, it'd be 10, and then the 1 indicates how many more zeros. That'd be 100, but I didn't expect it to actually be 100 microhenry. But it is, so that's a 100 microhenry inductor. You can change the frequency. Normally the 100 kilohertz gives you the most accurate reading. You've got the Q value there, so Q of a 60. But what we'll do is look at the circuit. We'll just write down 100 microhenry inductor, and I will look at what the circuit's doing, look at why that inductor's there, and then probably pick a better spec one. Again, usually on the old circuits, these inductors are all just chucked on like ground planes, and the gap between high voltage circuits and stuff, but they don't do anything. Like if anything, they add more noise because you're separating two zones, and then the inductor generates spikes and noises and backfeeds noise further onto another circuit. So they're normally worse than even having them on. But either way, we'll still put this on because we want it to be original. That is inductor. Is that L900 then, the big one? CC900, L900. Yeah, it's got to be. So that's L900. It's 100 microhenry. And that will do for that one. Let's get these off. And we'll have to label them with tape and put them in the tub. And this is basically the aim of the game. This is pretty much what we're going to be doing. Taking components off, measuring them. That one, to be honest, actually, certain components that I'm probably not going to source a replacement of just for this board, like this inductor, because it's working, it does its job, and it's not that important. I'll probably put this on our actual, well, the customer's new circuit. So let's just clean this up a minute. And then I'm going to actually solder it onto this board and start getting some things on. I don't think we want the things like the switches on there until last, because you don't want to melt the plastic. Anything plastic-wise I'm not going to put on until we need to at the end. And I don't want to do too much cleanup to this inductor, otherwise we risk, I don't want to damage the inductor by trying to make it too clean. Well, this is going to be a constant desk cleanup. I might as well just leave this Hoover out. Right, you can live back there for now. So first component going on the board. First of many, many, many components. This is a daunting task. Don't know why I even accepted this. Why have I listed this on the website as something you can actually pay for? So with the inductor, I'd normally hot air inductors on and let them pull into position, so let's do that. Pre-flow the pads. And then hot air. Let's try this new flux. That's the components on. And we should just get this to dance when it melts on, because the footprint is correct. There we go, pulling into position. And then if the air speed was hot enough, you'll get this to jiggle, like do the dance basically, but I think the hot air isn't, it's not on fast enough to see it like wiggling basically, so that's all you're going to see there. Oh, there you go. See that little wiggle there? That's when it's nicely flown. I'm just going to hold it down because there's excess solder on them pads. I put a bit too much on. Let it solidify, and then I'll just wick that off with my iron. Otherwise, it'll be slightly up in the air. That's now solidified. Take that little extra solder, wick it up. Now we want to clean this. There we go. Let's send it back to the customer. Done. Now we could nudge that slightly further down to make it perfectly centered. Might as well. Probably want a bit more flux on this as well, otherwise them pads are gonna go dry when we do this. There we go, better. So we'll slide him out of the way gently, then pull down over there. So we have that value component. Do we just move these chips over? Because I'm a bit bored of doing really, really simple things. Let's just let's hot air these 3 chips over, because they are going to be not really going to get in the way, and we might as well do it. So before I move that one over, let's put some fresh flux on these pins and check out if this flux is any better. Sorry, put some solder down on these pins, and let's just check if this HT flux is better or worse than that ASM flux. Both in reflow and in cleanup we want to see. It's a little bit difficult to see that, to be honest, with there being no silk screen in between them pins. It's quite hard to see the solder flowing. It does flow in very well, so I'd say this is better than the ASM stuff. Looks a bit burny though. The flux, it seemed to tarnish quite easy, but let's do that again. Yeah, this is flowing very nice. I think this definitely beats the ASM in terms of how long it seems to last on the board. So it flows just as well. Like the ASM flew nice, but this, I did all them without reapplying, and it looked really nice. It like beaded well, and it was going on really well. So I definitely think this one's better than the other one. Now, with using that ASM for so long, I can't really tell you if it's better than the V3, because I can't really remember the V3 now, because I've used the ASM for a bit longer. So I'd have to probably go back to the V3 to know if it's any better than this, but this is, just look how that flows. That's really nice, like no shorts, and just flows really good. And bear in mind, this hasn't got the silk screen between the pins as well, so it's quite hard to see, but that has definitely worked really well. Cleans up easy as well, so look how spotless them boards are now. So let's reapply some flux on here and get this chip swapped over. So can we get both into view? And you can see like a nice little hot swap. So let's just zoom out. Well, what I'll do is I'll do it like that. Well, I'll hot air this one off, and then once I've got it off, I'll zoom back in so you can see a nice reflow. And if we blow this diode off here by mistake, in fact, let's take that diode off. Remember, the green line is on the right side. I'll still position him out of the way, but I've got a feeling that diode's going to go bye-byes. So let's move him out of the way a minute. And this is the orientation he's in. So you can just about see the green line is on the right side. So that's the way it needs to go back on. I think there's less bubbling on this flux as well, which is good. So it won't move components as much. I'm looking for the bubble, and to be honest, this one doesn't really bubble as much. So in one way, it's harder to visually see when something's ready to lift off. But in another way, it's better because bubbling in flux just means you're going to knock components out the way. So that's also another, I think, positive to this. That's roughly in position. It's a big enough chip, we can do this easy. Hey, thanks for the compliment. So see how these pins are majorly misaligned left and right? You should see this chip, if I don't even touch it, this chip should just pull in. I think it'll be close enough that it'll snap into position and pull up. If we're unlucky, it'll pull down, and then we'll just have to nudge it up. But my money's on this is going to pull up, and if we're really unlucky, it'll just sit there and won't nudge, and we'll have to nudge it ourselves. So I think this should... Yeah, it's not going to move, is it? Oh no, it just hasn't warmed up yet. There you go, look at that. Nice little snap. So we haven't had to touch anything. I also haven't reapplied the flux, and at this point, you'd see me on the ASM flux reapplying at this stage to get them joints to reflow. And they've stayed there, and they're all perfectly fine and reflowed nice. So again, if we zoom into that, you can see how nice they are. I don't know whether we're slightly out of focus there or not. Yeah, it's just the digital zoom to its extreme, but you can see that's all nice there. Just holding it down until some of the pins go solid. And that will do. We'll clean it in a second, but yeah, look at them. Nice separated and flown pins, and we haven't had to reapply flux. Clean up easier as well, I think. So yeah, I do think it's very hard to judge. You kind of go from one flux to another, and you don't know whether it's like a, the fact that you think something's going to be better or not. I didn't really have any specific thoughts as whether this version of the flux is going to be better or worse, but this one definitely, I think, seems better. So alloy system, HT, maybe high temperature, so it's basically high temperature tachyflux. So maybe that's why this is lasting longer, because we're reflowing and it's not bubbling under the heat and stuff. So I'm pleased with that anyway. Diode will chuck on now, might as well. Just while we're here, so we don't lose him on the mat. I always try to do that with the soldering iron and it never works as well as with hot air. Try to warm up both pads, so I'm just going to quickly hot air him for the sake. Just put miles too much flux on there. Yeah, cleaning with melamine sponge works really well for cleaning. I know some people complain that they might be static, but I've worked on hundreds and hundreds of systems and never had one issue with it, so it's my preferred way to clean a board by far. I mean, you can see these, the white boards are not forgiving on dirt, and look how clean these are. We've applied these three, and you tell me where there's even a residue of flux. They're lovely and clean. Alright, so another hot air and swap. Flux ready on this board. Bring this board in. I think we've already got flux on there actually. We put flux on these chips as we went. Let's hot air this one off. We'll probably measure these VRs next, these little variable resistors, the pots over here. Just because I've got them new and I can chuck some new ones on. And again, there's no real order to this. It's such a big job, I'm just kind of chunking away at it and picking what I fancy doing as we go. And I might, to be honest, put the I might put all the transistors in as we go and measure them and, you know, get the specs of them while we're doing this work, and then we've got a much more fuller picture of what we're looking for when we try to replace these components. That lifted off, move that board out, move this one in, plonk him down, and again you've seen the idea, get it close enough like that, maybe try and get it a bit closer so you're not crazy far off, but anywhere like that, say that's close enough. And once all the pins melt evenly, you'll find the chip should pull into place. And based on this new flux, we won't even have to do anything. We won't have to reapply flux, which saves me on flux and time, because that last one we did literally moved the chip into place and reflowed all the pins and didn't dry out. So I think it was definitely better than the ASM stuff. I reckon the pull's coming in about 5 seconds. 5, 4, 3, 2, 1. Oh, not quite. This board's absorbing the heat a lot more than I thought. Oh, actually, I think it's just on a small pull. Just not all the way. Because the pins are now in line. Let's see. No, it's it'll still probably snap a bit more in a second. And I think, to be honest, I'm feeling like I want to apply some more flux on here. That's what my gut's telling me. And that'll cool the pins down a bit, but now, let's see if we can get that to pull in over here. Without, oh, I've accidentally nudged it with, I don't know, I've nudged it with the hot air then, or whether it pulled into position on itself. Oh yeah, they definitely knocked it because it's a full set of pins out. I've knocked it a full row over. But yeah, look at the flux again. It's had all this abuse and all this heat. That was a lot longer than we'd normally hot air, and they're all seamless. There's no joins, there's no dry solder. That is definitely better flux. There's no doubt about that. So let's just zoom out. We're probably going to have to wait about 15 seconds or more on this one because that was quite a lot of heat before we clean. I think that's solid. Yep. Give that a clean. We are very slowly working our way through a PC Engine. Well, PC Engine GT, the handheld version, or the Turbo. Is it the Turbo Express, the handheld in America? I think it is. And I'll give you a show of it. So we just put 2 of the chips on. And if we look here, we've got the customer's original board that's damaged and missing components, as well as the board's rotted. So we're slowly transferring all of these components over. But we are, at the same time as we're doing that, we're trying to measure the components on an LCR meter to find out what the exact values are, because there's no schematics for these. I've obviously remade the PCB and released this online so people can see all the internals of this PCB if they wanted to, and like fixed traces. But we haven't done a bill of materials for all the components, and there's a lot of components on here. I mean, look at this. There's a lot. So the goal is to measure every single component on here as we're doing this swap. So it's going to make this job a hell of a lot longer than it should be, but it's something I've been wanting to do for a good while, is to basically do this. I said the next time I get one of these swaps in, I'm going to measure every component. So I've kind of had to stick by that because I've been saying it for so long. So we are basically measuring all components and trying to find new replacements for them. PC Engine is like this. It's like a handheld, similar to a really chunky and old school looking Game Boy. This is obviously in bits at the minute, so you've got the cartridges that go in the back, which I have somewhere. So we've got called Hue cards, and the Hue cards, basically little cards that slot in. So you got things like the R-Type, Space Invaders, popular games. You got like all, like that's a Japanese game, Dodgeball, I think it is. But these just go in, the back of the console, like that. Obviously the connector's not in at the minute, but they just go in there. And then you turn on and you've got like a Game Gear style screen there and some buttons. And obviously these are from, similar to the Game Gear plays like Master System games. The PC Engine is a little desktop console, and the GT is the handheld version of the desktop console. So they're basically playing the desktop games, if you will. These aren't just games for the handheld, they're actually games for this specific console. Just realised the camera's locked. Ooh, that face cam gets well hot. Right. Get that third chip over, and we'll get the RAM over as well while we're at it. Yeah, we use lead-free solder. Sorry, not lead-free solder, leaded solder. And this we will apply a bit more flux in case it's disappeared. Apply flux to the new pad. And now let's do another swap. Let me do what I actually said I was going to do. Or when I was doing like the RePCBs, I'm going to put under the desk the bit of cotton towel so the flux gets absorbed underneath there and doesn't stain my silicon mat as much. Ooh, 200 stars. I don't even know what that is, to be honest, because I've only just recently started streaming. So I don't even know like what platform it's on or what it is. I presume that's Twitch, at a guess. You'd have to let me know. I literally have only just recently started doing the streaming stuff. Ah, Facebook, cool. So it even pulls in them from Facebook. The only thing I wish it did was actually link into TikTok better, because we have to have a separate window open for TikTok chat, because 9 times out of 10 it doesn't pull it in, and I still think it misses a load of chats because I get quite a few people thinking we haven't answered them, or I'll get comments that are clearly mid-sentence comments where they've asked a question before, so that the TikTok integration isn't great. And we do get quite a lot of people viewing on TikTok. So let's align that roughly. I've done the retro repairs now for like 7 years. I do software as my career in a sense. It's what I've always done since I was young, like 10 years old. But I've ran all kinds of businesses. But this retro one's 7 years. Hardware on and off. I did some about 15 years ago, made rapid fire chips for Xbox 360 controllers. So in Black Ops, like Black Ops 1, for example, I made a controller with a little mod in called an arbiter, and it'd allow you to say like tap LT, and then it would automatically say run, slide, shoot. So if you've got like a spaz shotgun out, it would shoot the shotgun, toggle to the next weapon, and then shoot another one. So you could do like a double pump and slide by just tapping LT. I then went into like making the mod do quick scopes and all kinds of things. So I did that like, I bet it's like easily 15 years ago now. And then I didn't really do much hardware after that for a while. Went back into software, and then with retro I've kind of come back into hardware. So a bit of everything. I just like doing stuff. So yeah, that's that. It's all self-taught. There's no education. So I wouldn't say I'm official in any of it. It's just all I've taught myself, everything I do on here. So tell you what, this whiteboard absorbs the heat much more than the green. That still hasn't reflown fully yet, so even though it's in position, we still need more heat on this board. That's crazy. There we go, it's finally starting to move, and I'm still gonna put that little bit of extra flux on because I think it helps. But I've got to get used to this flux not bubbling like the other one, because that was always like a nice indicator of where it's at with the heat. Now I don't really know. I just have to nudge to see if it's actually liquefied or not. Just seems wrong that this board takes so much heat. Feel like that one's moving a bit. Yes, it does. There we go. That's the flux popping. Oh, Just trying to read a comment and hold tweezers on and knock the chip off. Let's nudge him back on. There we go. Fix that mess. Right, let's try not to nudge the board when I stare at a comment this time. Put some extra flux on this time, reflow them. And then we're just waiting for these to go. Well, you can't really see so much on the camera, but basically turning from shiny to dull as the solidify. It's a bit hard to capture for you. And then once it's solidified, we can let go. And then we give it another 10-15 seconds before we wipe. And you want to try and remove the flux while it's still warm, because it wipes off much easier. So that's why we're trying to time it just right, that when we wipe the flux off, the solder is solid and we're not making poor solder joints, but it's not cooled down enough. So we end up having trouble wipe the solder off, the flux off. So that's like the perfect timing. This definitely cleans up easier than the other as well. You can see on the back there, this mat or this cloth will burn, because it's obviously not a high temperature cloth, but it captures a lot of the flux running through and keeps the mat underneath a lot cleaner than it would be otherwise. And I'll replace that mat now with a new one. Yeah, I'm pretty sure I've got the pin 1 on right, because I lifted it straight off and moved it over. I also took a photo before I started doing this. Let's just take a quick look at the photo. Yep, that's on the right way. So I've got the photo there before I started working. See, that's on the right way. And now, using my phone, I've decided to get flux all on the back of the phone now off my hand. Right, that's them 3 on. So it doesn't look like we've got far. We've put an inductor, a diode, and 3 chips on. But we do have a bag of components with, this was all the difficult stuff to remove. We've got the 3 plastic connectors, the power switch, the high voltage switch, 1 wheel that survived, 1 got destroyed by me at the very start of the stream with hot air, this choke, and this doesn't matter because we have a brand new one. We have then another connector of that, TP509. What did we write down for that? That's the DC jack, but one of the viewers found the right one on eBay, so we've already sourced that one. All these others I'm just going to send to, like, not this for example. We've got that, but everything here we're just going to send to my factory in China to find me alternatives for me, so I don't even have to try. And then that's easily done. So actually what I might have is a tub that I'm going to send to China, so that's this one. And then another tub for components that we've either found ourselves and we can purchase, or that don't need, like, we know we're not going to get one of them identical. Or I guess, no, we can try China, see if they can find that. CN500, that was not written down. What's CN500? I haven't wrote that in the BOM. That's a connector for the battery, so I need to write that on the BOM. We're also keeping a chart here of all the components we're taking off, and then I can put this on the wiki for anybody that wants to know what they are then. And the idea is, not TP500, what did I say? It was CN500. Yeah, definitely I've got CN500. No, so battery connector. Yeah, the goal will be when I've got all these parts from China, like sourced, I will also put that in there then. In fact, all them are, because I'll still send that connector to China even though we found it, and they can source it. I'll sell like a bag of all these components, all the ones that are basically like the plastics that you're going to lightly melt. So all of the wheels, DC jacks, audio jacks, battery connectors, all of those things I'll sell as one little kit. So people that are doing these kind of swaps are 100% going to have issues like that. So we'll be able to sell that as a kit. I might even sell, I don't think there's any point selling the components as a kit because it'll take you more time to take them out of the bag and put them on than just moving them over. But what we will do when we've identified all these chips is to, as I said, populate this board entirely at factory. I can even ship the existing boards back to the factory, have all the components soldered on and brought back. And then when we're selling this board, it's mostly assembled because we've got all these components to do as well. So we have this backside is even worse. This is, yeah, there's just so much going on there. So we'll work our way through this. I'm half tempted. Don't quote me on this, but I do this sometimes and I'm kind of tempted. I don't know whether just to pull an all-nighter and do a ton on this, like come back on at, I don't know, 9, 10 o'clock, maybe 10 o'clock. I just work through the whole night doing this, but all depends on Rusty, because if Rusty wants me to go bed, because he comes up bed with us, so it's going to be hard to get him to go to sleep and me to sneak off, so maybe, maybe not. Or what I'll probably do instead is let them go asleep, wake up at about 1 or 2, come down and carry on. I might do that, because when it's a big task like this, I kind of just want to just work through it and, you know, eat away at it when everything's quiet and I don't feel like I'm eating into the day's work. I can, you know, work in the middle of the night feels like free hours and you've gained a lot. Blue mechanics towels. Yeah, maybe I could give that a try. I think the bamboo ones are just nice and quick and I use them for cleaning as well. So I can give them a try. This project is basically taking all the components off of an existing PC Engine GT, identifying them and sourcing replacements where we can, swapping chips over where we can't, like these, and basically trying to get this whole board moved over to here, including all of the back, which is, I shouldn't keep looking at it because it puts me off. All them over there, but every single chip I'm taking off, and like every cap we're going to come to and take off, I'm going to make a note of what it's measuring, so that we can identify all these chips. But it's pretty mundane, pretty mind-numbing in one way. I think if I wasn't doing a stream, I'd be bored shitless already. But it's a little bit better if we're streaming this because we can have a chat while I'm working. So, but the irony is, I normally get tons of chat, and now I'm doing a really boring job. We're barely getting anybody chatting. But still better than sitting and doing it on your own. So that's got the solder on that pad. The flux looks like it's still good to use. Let's hot air this off. This is I think it's the work RAM. Could be video RAM. I'll just put RAM on it for now, and then I'll look at where it goes and what it does and stuff and figure out what it is, so I can just make a note on the bill of materials, whether it's work RAM or video RAM. It might not even be either, but pretty sure. I'm trying to read the part number, but I'm pretty sure it's RAM. F08H607, or could be that. Can't quite read it. SRM 202. Yeah, so 20256. It's going to be 256 kilobytes of RAM. So it's definitely going to be RAM. Just whether it's video or work RAM. Oh, that cap's just stuck to my iron and lifted off. Stuck to the hot air. Oh, we're getting the smell of electrolyte now. There's been some leaking caps in that area. Get him on there. Hey, you're welcome. Glad you're enjoying it streaming. It's keeping me busy as well. Like I say, having a few people to talk to while I'm doing this. No, this is going to pull into position hopefully in a second. 5, 4, 3, 2, 1. 0.5. 0.3. 0.2. There we go, 0. Yeah, so this new whiteboard is really tolerant to heat, which is good. That's flown in really nice as well. I like that footprint. Yeah, the turbo, the PC engine is confusing as hell because obviously America have got the turbo side of things, and then Japan and the UK have got the PC engine. But I think the Turbo Graphics 16, I think, is the desktop version, the same as the PC engine. And this PC engine GT is obviously then the Turbo Express, I think they call it. And then we have the PC Engine Duo, and I think you guys have the Super Core Graphics Effects something or other. There's so many names and so many variants, and the names are all totally different. So it's always hard to remember. But I've worked on quite a few of them now that I've started to remember the names usually. I think I've got that right. So I think UK is PC Engine and PC Engine Core are the desktops. Then the GT is the handheld, obviously. And then the Duo is with the CD drive. And then the Super CD is the combined PC Engine and CD together. And then in America, you've got the Turbo Graphics 16, I think is the PC Engine. The Turbo Express is the PC Engine GT. The Super Core Graphics, I think, is... I don't think that is the Duo. Not sure what the Super... I know I've worked on them. I'm just trying to think what would they actually relate to. Not quite sure. But yeah, what is the CD version called in America? Or the CD add-on version? I'm not actually sure of that one. Can't remember off the top of my head. Right, so he's on, that's on. Let's clean up that, considering we've got a lovely whiteboard. Or is that actually... Yeah, it's just a bit of dirt on. There we go. Sore neck, sick of bending over now. Right, what next? We've done some chip swaps. Do we measure some components now? I wonder if as well, what I'm going to do, I've got a bag of the parts I took off my working, the one I stripped to make this board. What I should probably do is, out of this bag, get out the parts that I want to send to America and put them on the customer's board, ultimately. Like, not now, but obviously keep them out of the way, ready. So I've actually got... Yeah, that's one off mine. That does look more like a Game Gear one as well, so the Game Gear ones almost definitely will work. So we don't need to clone them then, because I'm going to have tons off Game Gears. I'll start salvaging these off Game Gears, and we can put them in the kits as well. So that is still on the customer. So what I'll probably do as well is I'll just leave that on, or mind you, we could hot air that off now. There's nothing else around it once we do that side. The audio jack I've got new, so we don't need to send that one don't need to send either of them to the factory. I'll grab a new one. Let me see if I can actually find the new one in here. They might not be loose in here. No, so the headphone jacks are at work, so I'll have to grab one of them tomorrow. But we don't need to send that because I've literally got the part number. Those chips are off my... Wow. They've got battered. Good job I don't need them. Look at them just being pushed around in the bag. These are all perfect before I lob them in the PC engine tub. Those connectors are going to the factory, so we've got 3 spare there. So we'll take that one out. Take that one and that one. What I'm doing is basically putting my beat up connectors in this tub that's going to go to China and keeping the customers out so we can actually put them back on the board. Otherwise, we're not going to have the components for the customer. So I didn't think of that at the time, but that's what we'll do. Power switch again, that's ours. So we'll put ours in the tub, keep the customers out. Same for that, so we can actually solder that on the board. So we'll chuck him on in a second. That is the... Actually, there's a point. Is that on there? That's got nothing to do with it. Ah, there's the DC jack out of mine. So we can actually use this for the customer before we're waiting. You know, we don't have to wait for the other one to come. So we've got a usable one for the customer, so that's good. I will put that over there. That we're going to try and hot air off. Yeah, we sell the board. Literally, we sell these whiteboards on retro6.co.uk. So if you went to, let's see, retro6.co.uk, drag that over here. If I open that up, so you go to retro6.co.uk, go to mods and kits, scroll down to PC Engine GT here, and then we've got, there's the headphone jack that we're going to replace it with. We've got the audio IC, so the audio amp, because that fails common, and this is the RePCB. We've got both white and green, if you want to keep it stock green, and we do the white because that's our colour, basically. So if you want to grab that board, you can from there. And then what I'm going to try and do, like I say, is send them back to the factory at some point and have all these chips soldered on. Crystal, we don't really need to send back to the factory. That's just a crystal. That'll be easy to spec. We've got one of the little coils. This is T500. So maybe we'll send that to the factory when we take it off. I think we will. So I'm going to keep out them 2 coils, and I'll still send them to China to see if they can source anyway. I suppose might as well. There's that battery connector, which was, what was the battery connector? CN500. So that's CM500 taped up, which means we want that one going to the factory, that one staying out. Random inductor cap, that won't help us. What's going on there? So we just got 2 potentiometers that I took off my board that we'll keep out. Put them on the side. This is the to go to factory tub now. And let's just put this back on. So we've got the choke on here, so this can go back in here. We might as well solder this down. So we'll poke him through. Zoom into there. Pull focus would be nice, fancy little pull focus. And there we go. We can, what we'll do is solder one leg on so he stays in place. Like so. And then when you turn over, you can see that it's not flat on the board. So what we do is we push down with a finger while we warm up that one solder point. And he now pushes down flat on the board. And you can then see it's all nice and flat on the board. You can see all that's nice there. And now we will solder the rest of those points. That's it. And then what do we do next? I want to say I want to hot air these off, but these components are still underneath, so we'd have to, let's try and hot air these cages off. New technique. This is just the cage on top. Considering we're not that worried because we've got spares of these, I'm going to try and hot air in just the cage itself and see if that makes, I presume it would, but makes the entire solder pads melt. And obviously this isn't touching the things inside, so it's not going to overheat the component underneath. I just want to see if hot air in this, if we can just lift it off nice and easy. The hardest thing is going to be grabbing this. What can I grab it with? Try it on this one first, the smaller one. Because I can at least grab that with something. I don't think anything big enough to grab that with all my tools are small. There we go, just about. Yeah, the idea will be offering, once I've identified all these chips, I'm going to probably send the stock back to the factory, have them populated with everything that we find. Oh, look at that. Wicked. So just warm the cage up itself, not the solder pads, and it just lifts clean off. Yeah, so once I've identified all these chips, we'll send them off to the factory, get as many sourced as we can, and then do a bit like basically a small assembly run to make these all into populated ones. So by default then they're just going to be sold populated as opposed blank. I think this cage is just stuck on some of that thingy, to be honest. I think this is already off. It's just stuck on this white gunk. Yeah, there we go. It's just like caught on something. I've got literally nothing. No tools big enough to grab this thing. There we go. And that is, yeah, that's definitely, now you look at it, I think that is a Game Gear transformer. So if we get that off, we can turn upside down, warm up, and it'll just drop out. Because the weight of this will just literally pull it through. So that's all we've got to do. There we go. And no other components have come off. So we have this now, we can put back on or send to the factory, and we've got the spare. So we'll keep that one there. We'll send my one back to the factory that I've already taken off. So that can go in the tub over here. And now we will take off this T500 here. So I'll take this little one off as well. Clean screens have been requested quite a bit for these. I probably will. I've got a new Game Gear clean screen version 4 coming out next, which is a brand new design. That's way more powerful, so I've got new capabilities, tons more memory, so we can add all the features we wanted. I'll probably then, I can either port that to GBA next, which I think I'll probably do, so the GBA can have the benefits, and then I probably want to make the Game Boy original, colour, and Pocket all in one go. But after all of those, the PC Engine is probably next in line, I'd say. Right, so we have this one that I took out of mine, going to factory as well. The cages are no longer needed. And we'll put those, I think, back on to the transplanted board. So we'll get them onto this. We'll do this one first. Yeah, the new screen, the ones we're putting on for the customer, or the clean screens if we ever do, they don't need. I don't think they need either of these transformers. I'd have to look on either the wiki or the schematic notes. There isn't a schematic for this as to what does what. This is the backlight for the fluorescent tube, so I know for a fact that's not needed. This, I think, is for the contrast voltage that allows the pixels to twist in the screen. So I'm pretty sure that's what these two are, but I'm just going off the top of my head. It's been a while since I've looked into the circuit of this. So these aren't actually needed. I'm just putting them back on for cosmetics, really, just so the customer has them on there. Is that the flux I haven't cleaned? So look at the... that's got to be the flux I've not cleaned, right? So that's the new flux. I've not been bothering cleaning this board. Cleans off nice and easy, but yeah, that's... I've never seen flux dry like that. That looks really easy to clean. It's normally sticky and tacky and messy. And this looks like it's just dried like a bit of honey. So it definitely looks easier to clean as well, even if you don't get it off when it's warm. I love that little follow focus wheel it says. Or the focus demand wheel. There we go. Nothing nicer than cleaning a board and it being a white board and just looking immaculate. I just need to move this camera as well. Overhead, unlock. Let me just move that slightly this way. There we go. It's more visually correct. When I'm looking at the horizontal, that's actually centered on the vertical as well. What are people thinking about the horizontal streams as well? Because you can see like on YouTube at the minute, there's just 30 horizontal, but we have usually 100 plus now vertical YouTubes, and TikTok we get over 100 normally viewers. So it seems like the vertical is more popular. Yeah, I kind of started all this for the fact that I thought more people would watch horizontal, and literally we get 10 times more people watching in the vertical layout. But I guess now I've made the vertical that nice, but like, and I'm bigging myself up here, but I think the vertical layout of the stream is really good. You can almost see just as much as the horizontal layout. Oh yeah, I'll be doing full ceramic caps on this. There'll be no aluminiums going on anywhere. So we'll be doing them caps last. Right, we'll put this transformer on now. Oh, geez, that's hot still. Picking that up like it's not a big lump of metal. So he can go on there. Yeah, so horizontals are still... Obviously, I'm not going anywhere with them. I'm not asking that for any reason. I'm not going to drop horizontal. It doesn't change anything about me streaming both ways. Plus, I need to visually see what I'm doing horizontally on my screen. Otherwise, I couldn't work, doing this work looking at the screen, because I have to look at the horizontal screen. But I just find it curious that there's so many more people watching vertical than horizontal. I suppose it's just a time, like a bit of change in the times as well. A lot of people kind of scroll on the vertical a lot faster than long format, I guess. Right, so we'll put him in and flip this over. Same again. What we will do is solder one pin in. So we'll pick this pin as the one we're going to solder. And then we will flip the board up on its edge, say. Use my super fast little focus wheel. And now it's not quite flat. So I'm going to push and, well, actually it might be flat, because we haven't even soldered anything that side. I think that is flat. It's just visually looks a bit up this side, but if anything, what it might be is... let me get some solder on. Right, it might be this blob of solder here. So if I warm through with an iron, there you go. Now it's pushed flat. So that blob of solder was stopping it going through the board. So we're nice and flat now. God, that camera's so sharp though. That's really nice. And then we can finish soldering these solder blobs now. So pull that down. Yeah, I think that's it, isn't it? It's just a lot of people are on phones casually browsing, and they probably... I think the one thing I notice on YouTube is, even though these are like, multiple hour-long streams and there's not that many on, almost everybody stays for the whole stream. Like that, you see almost 100% retention of just, once they're watching, they just leave it running. Whereas like most other videos, even all the popular TikTok videos before, get 10,000 views, but the average view time could be like 30 seconds out of a 5 or 6 minute video. So the views aren't exactly that telling, as much as the fact that this is almost 100% retention. Like doing the streams, I almost get entirely people joining and then never leaving, which is quite good. That's another one done. So we're getting there. See, the top doesn't look too bad. You look at the top and you think, oh yeah, we're not far off. It's just this damn side I keep flipping over to. Right, so next up, we could almost systematically work diagonally down now as well if we wanted. So Q500. I don't know if I've got a component tester anywhere. I'm going to probably leave the component tester stuff till last because I don't know where it is. Diodes are just diodes. They're pretty basic. Just a simple diode will do for that. This, we should hopefully be able to find this high voltage cap. If I can get that bloody studio light glare off. Somebody wants to Google 39 3 kV. That'll probably be 3000 volts for the backlight, so it's probably 3 kV, and that's maybe 39 picofarad, might be 39 nanofarad. So we'll put this through the component tester, and I'm going to presume the 3 kV is a 3000 rated, 3000 volt rated cap. Let's see if that turns out to be true. So there's one pin under this. There it is, and the other pin under that. Doesn't help that all this silicon or whatever it is holding it in place. So I'm going to go from the top now. Now I've got it mostly out. That's it. That's that one out. Nice. Yeah, I've never done the magic stuff. I had a few friends that did, but I used to sell them. We used to have a little game store locally, selling plushies and Pokemon cards, and we expanded into like magic. And I never got into it. Never had enough people to play with, but it's obviously mega popular. And then it's the Black Lotus, still the most expensive single card, the original Black Lotus, or has that been dwarfed by something else? I think didn't they just stop making it and then they'd never make it again, and they're never going to make anything that powerful. So obviously I think it's banned in most competition play because of that, but it's purely a card value because there's not that many of them, I'm guessing. New components to replace stuff. Yeah, that's what we're trying to do here. So a lot of what we're trying to do is take these components off, measure the values, and find new versions. TDK, yeah. So 39 picofarad. That's what I thought it might be. So that DigiKey reference. I'll put that in the spreadsheet. Nice one for that. We pull up that spreadsheet. This is C901, so C901, 39 picofarad, 3 kV, part number, doomph, done. A load of the rings have got cords. I didn't know that. Never even seen them, I don't think. Alright, so let's measure this one. So we know what it should be, pretty confident. So let's see how it measures. And if you don't have a super accurate LCR meter, then you won't get accurate readings. There's no point measuring. Like you get so many people that obviously they don't buy the decent stuff. This is peak tech and it's calibrated yearly and stuff, so it's all within spec. And if you don't know how to use an LCR meter either, by changing the frequencies and understand the principles of it, then there's no point measuring components. So you can see this is showing 45 picofarad, and then you let it settle, it's gone to 39.9. If we change the frequency from 1 kilohertz and go up, this will drastically change some capacitors' values. So 39.5, you go to 100 hertz and it's 40. So because this is small, you're not seeing such a drastic change. But on larger caps, this will make a huge difference. So if you were to test a fully working, I might as well show you. I've got one. Well, I actually do have one. A common mistake that people do when they try to measure caps, if they'll go to do a recap, they'll buy a cap kit online, and they'll still seem to want to test the caps with like a cheap-ass LCR meter and go, oh, your caps don't work, they're wrong, and they just don't understand how caps work and how LCR meters work. So let me give you a quick example. Take a brand new cap, known working one from DigiKey, big long ass part number, but this is a 1.5 millifarads. This is a massive capacitor. So if we clip on there now and let this read, you can see it says open line. So you're like, oh, so this is a dead cap. It isn't. It's that large that the charge time doesn't work, and at 10 kilohertz, it's not showing as a cap. So if we change these to different ones, you can see now at 100 kilohertz, we're seeing a resistor. So if we tell it forcefully, we know it's a cap to measure just a cap. At 100 kilohertz, it's still open line. At 100 hertz, however, it measures at 1,400 microfarad, which is within spec of the 1.5 millifarad. But the frequency matters when you're testing caps. So at 100 hertz, this measures correct. At 120, see how it's dropped nearly 100? Massively changed. That's not a faulty cap. That's how they work. They change with frequency. At 1 kilohertz, it's now 1.3. At 10 kilohertz, it's now open line. So this is why caps like this wouldn't work for obviously high frequency, and they're not designed for it. These are designed for bulk capacitance and smoothing. So you can't just like plug in something and go, oh, this cap's faulty, or it's a certain value. They have different values at different frequencies, and if you want to test them properly, make sure you kind of read up on how to properly test caps and use an LCR meter, because it's not just like a resistor where you're just measuring resistance. And yeah, you get quite a few people that'll like say the cap kits are wrong, and then they show you a photo of how they're testing, and it's just literally a cheap LCR meter that doesn't really test it correctly. Our Game Boy flash carts, just empty carts where you put your game. They are, if you buy them off us, you might find they've got quite a few games on. But officially speaking, they're empty cartridges that you put your games on. And I've got a load we're building up for customers right here at the minute. So we might as well put this straight onto the new board, because we know what this cap is now, so we don't need to do anything or send that anywhere. I'm going to put him on this way, so it's obviously got a big bend in the board. I don't know how it come off, whether it come off that way or the other way, but that way is nicely out the way of everything. You can also solder these as well from the top if you want. So you don't always have to turn the board over. If it's rested nice like that, you can just blob solder on the leg and flow it in from this side. And if you leave your iron on long enough, you should find that solder has flown through to the pins just the same as soldering it from the top side. Connector over here now. Yeah, the switch, I'm pretty sure, unless I've got my terminology backwards if I wasn't thinking straight, it's got 2 rows of switches, so it'll be a dual pole because there's 2 poles, and it's a single throw because there's only 1 pin inside throwing, so you haven't got like 2 pins throwing left and right. There's a single pin sliding between 2 poles, so I'm pretty sure it's a single pole dual throw. Let me have a quick look at the diagram of a single pole dual throw switch symbol, and then I'll know. It will be actually a single pole dual throw is a single line, so it isn't. It's a dual pole dual throw actually. So a single pole single throw is just an on-off switch like a push button. The single pole dual throw is like 1 line of the switch. So this would be the single row here, the single pole, and then dual throw because, so the throws are from the center connecting to here or here. There's your dual throw now. And the pole is, there's 1 here, and this is another one doing exactly the same. So it's actually a dual pole, dual throw switch, that is. I usually get them right, often get them wrong. Fume extractor, I should do. I'm not really doing that much soldering at the minute. So I've got now in the room an air purifier that's cleaning the air. It's literally running now and pulls all the particles out the air. But yeah, I do have a fume extractor. I have started putting it on a lot more. You can see right there, that little 2 UUL filter. And then if I swing it all the way around, we've just had in this. So I've got this little shark. This has really helped in the room as well because this hasn't got much airflow in this room. And with doing all the soldering, it's quite a room that's lacking a bit of air. So that's really helped putting that in the room. Like it feels a lot nicer in the room now. Switch, yeah, well, I was considering how over here. I didn't know whether to just chuck this connector back on now because there's nothing really in this area. No, there is, there's all this. So we don't want to put that on yet because we'll be hot airing stuff here. So what time? We're over on 6:30 already. So I'm probably going to get some food, to be honest. And then I'll either be back on, well, this is basically the next job. So I'll be on and off this now on stream. I'll probably just do this entirely on stream. I can't see me doing much of it off stream because it's just monotonous, but we'll just carry on this. Tomorrow I'll find the component tester so we can test components, and then we can either work away. I think we'll do all this top first. So we'll probably just work away from here down the board and get this top side done. That shouldn't take much longer. The top side will probably take another half hour to an hour, probably an hour on stream because of the chatting and going back and forward. We'll get that done later today or early morning. And then we'll go on the back side, and there's nothing else special on here now. So all this will just be taking components off, measuring them, putting them on. So I think that the long work we've done, like the metal cages, the transformers, the switches, the plastics, all the hard work's kind of done. These are just all now mostly passives and quick components. So it looks daunting, but I don't think it's going to be that bad. And then we'll see where this at, because the customer had issues with both audio and video, and we have no idea whether this works or not. So we'll find that out at the same time. But I think I'm just going to wrap that up for now. I'm getting a bit peckish and thirsty. And I'll obviously, I'll either come back on tonight or very early morning, or if not, I'll just come on at 5:30, 6 o'clock-ish, like normal time in the morning. I'm thinking, depends which way around I do my day. I might do the software late on. We'll see. But I'll be on at some point. You know me and planning with these streams. I'll just appear randomly in the wild. Do I have those cards on the website? What cards? What cards are we on about? Dual pole L-shaped mount switch. Ooh, I tell you what, if you found them switches, that'll be good, because I'm sure I remember looking for them switches myself and I couldn't find them. I'm sure I did. Has that got... Is that showing multiple pictures? Yeah, it's got multiple pictures, so it's one of them it's showing. Oh no, it hasn't. It's there, isn't it? Yeah. Yeah, I think that doesn't look far off. I don't think it gives a diagram of pin positions, but that does look potential. So I'll put that link in the spreadsheet, and I'll order some, and I'll put a question mark by it that, you know, it's potentially that one. So power switch, maybe, and then that link. We've got that in there. Right then, so I'll leave this all out, and I will be back when I'm back. How many hours do I work in a day? Up at 5:30. Knock off. Usually I knock off around nowish, but then I'll go for like a coffee break in the middle of the day. I'll work when I'm sat on the sofa now all night, just on and off with like emails, customer service. I do that permanent, like middle of the night. If I wake up, I'll start doing customer service. Just whenever. I wouldn't really know my time. I don't kind of clock it, but more than most people, I'd say. And time to go and see Rusty. I'll catch you guys maybe today, maybe in the middle of the night, maybe tomorrow, maybe not. We'll see.